Alright, welcome to a rare early morning video. Last video I had to cut it short and stop it here. So this video is going to begin with this file here, log_test.py. Okay, and we won't necessarily need a virtual environment for this because it's using the standard Python library, so I don't need to pull in custom modules. But we'll activate one anyway, just to maintain that habit. Okay, so now we need in this folder here a file called log_test.py. The root logger is the parent, and a new logger called myApp is introduced. Executing the file directly gives output in the terminal as well as in a file called application.log. So let's run this. The command we're going to use is Python 3. They're using the command Python. And actually, to be honest, now that I have this virtual environment enabled, I can just use the command Python. Oh, really? Oh, you know what? I don't even have Python installed yet. So we're gonna do a apt-get update, and then we're gonna install Python 3. And having the virtual environment activated during this, I don't think will make a difference. Because we're using apt-get, we're not using pip, so it doesn't take the virtual environment into consideration. The apt-get command doesn't. Pip it would matter whether it was enabled or not, because pip takes the virtual environment into consideration when it does its actions. I think I could be wrong about that, but let's do an apt-get install Python 3. Okay, and hopefully I can just use the regular Python command. We'll test that by opening a Python interpreter shell. And there we go. We've got Python 3.5, so I don't need to run it using this, although I do have that option still if I would like to do it that way. But we'll just, and that might be necessary if I had a global environment. I didn't have my virtual environment activated, because if I had multiple versions of Python installed, I would have to specify which version I wanted to open a interpreter shell to, especially if by default it opened a version that I didn't want to use. So that's another reason why activating a Python interpreter shell is such a good habit, because you can just use the Python command and it already knows which version you wanted to use because of how you built your virtual environment. Okay, so we've got logging is not defined. Makes sense to me. We didn't import the logging module. And we can see that there never was given a command to import the logging module, so I'm not sure why that's missing from there. Unfortunately, this book I'm less and less satisfied with as I'm uh, entering into this chapter. There's been a number of, most of the typos in this book have occurred around this section of the book. And I'm kind of a stickler for typos. I think the more typos there are, sometimes it says a lot about the publishing process. Okay, so the name of the library is logging, and we can see that was used here to build the logger. Okay, so we got the output. This is an info message from the root logger. We didn't get my app, we didn't get warnings, so I'm not sure what happened there. But I think actually this file log_test.py was meant to have some of these prior lines in it. Yeah, because here we would have the base format. So I think it was meant to have those lines. Those lines are missing. So you know what? I'm going to go ahead and add them. Okay, and we're going to use the new school style of Python syntax. Okay, so this is the equivalent way. You'd have to put an F like that. This is the equivalent way to write this sort of syntax, but using standards new to Python 3 and standards that are more accepted going forward. This is an out-of-date standard. Okay, so now everything turns green, so we know our syntax is good. We've got all of our brackets are closed, all of our curly braces are closed, so that looks good to me. Next line is going to be defining the file format. We're going to have a formatted string, so we need that F there as well. Okay, and then we'll call in our base format that we defined up here. Looks like we've got a few more lines here. Okay, I'm not sure if they want these lines in there as well, but we'll add them because what's going to happen is it's going to redefine the logger if we include these after these lines. So we'll get the output that we're looking for a few pages later in this book, even if we add the prior lines that define the root logger. It's going to get redefined. So it'll blank out anything left over from the prior pages once we get to that other section again. Okay, so here we've got kind of the error that we found before. There are using a method that belongs to what looks like a console_logger class, but I don't see where that class is either invoked or defined. We can see where the file logger class has been invoked here by running this file handler method, which builds a class here. So we do have a class object for a file logger, but we don't have any sort of similar object for console logger. So last video I looked at this and I made the determination that, oh, it looks like they meant to have the file logger be used there. I mean, I guess it could apply to the root logger too, so I'm really not sure which one it is meant to apply to. Actually, it's meant to apply to the file logger, because you can see the root logger, we pull in that file logger here, so we want the attributes given to this file logger through these class methods here. So we want to set the formatter of the file logger, so we have to do that to this file logger object and not the root logger object. All right, moving on to the next part. So now we've got a console logger. That's another clue that they actually made a mistake there. Looks like they got jumbled up this next section. Alright, so this looks good to me. Let's save it and run it again. And oops, so it looks like we do have a syntax error here. So let's think a bit more carefully about this syntax here. We can see at first glance everything seems to be fine. Yeah, so I'm not sure what the syntax error here is. Now, I know there's a okay, so I know there's a debugger we can use here on the file, so let's try that. Okay, so we used the debugger here, and we can see that we do have some more information here, but unfortunately I don't think that information is all that useful. We need to figure out why this is invalid syntax here. So let's go back into the file in the nano editor and take a closer look at this line. Yeah, I don't understand why this isn't valid syntax. Let's look at some details about Python versions and see if that format syntax is just simply unavailable in Python version 3.5. Yeah, so we're going to Google for Python f-string formatting, and here we go, Real Python. That's a really good trusted source. In-depth, a lot of really good stuff there. One of the things I might want to do at some point is, probably for my wild networking series, is go through some of these tutorials because there's a lot of really good stuff. There's actually DevOps courses on here as well. Unfortunately, the search is broken, but one thing you can do for Google searches is you can do site real python.com, unless it's a .org, I'm not sure. No, it's a .com. And I think that's the syntax. Yeah, so now that I have my site set to that, all my searches are going to apply to that site. So if I search for DevOps, I'm only getting results from the real Python website. So, it looks like I'm actually getting a result from another. So I don't think I used this syntax correctly. Let's go to another site, the advanced Google search website. Okay, so this is how you can do that without having to memorize the context. So we can go down here and we can say site or domain, realpython.com, and yep, any language, any updates anywhere on the page, perfect. The other thing you can do that is really helpful sometimes is narrow it down by the format. So if you're looking for a PDF, you can make sure that you're going to find a PDF. Okay, so we're going to look for this exact word or phrase. It's going to be DevOps. And then we're going to click Advanced Search down here. And now we can see where I was incorrect in my syntax. My syntax that I was trying to use was site. Yep, we can see it right here. But the proper way to do it would have been my search term here. And if I put it in quotes, I'm going to make sure I get exactly that search term. And then with no spaces, site realpython.com. And now I only get results from the real Python site. You see I don't get that extra result I had down here where I used the syntax incorrectly. And the tab I just closed, I actually, that was the result from my advanced search, the website I used. I mean, I would recommend if you want to use advanced searches, just pull up that website. It's easier, you'll get the syntax right. You'll save yourself time in the long time, and there's no need to just memorize something for the sake of memorizing it if you barely use it. But yeah, we can see we've got all sorts of free tutorials relating to DevOps and Python. Expansive, yeah, DevOps with Python. Oops, I gotta take a break. I'll be back shortly. Alright, I'm back from my break. Let's keep on going. So I think I've got all the code. Oops, so we had an error here. So you know what? I'm not going to waste any time with that, and I'm just going to use the syntax given in the book. I guess I am really curious why this didn't work, because I really thought it would, and I don't want to be in a situation where I think something will work and it just all of a sudden magically does not. If I'm ever in that sort of situation, I want to at least have a sense for why. But time is of the essence. I've got these videos are usually pretty darn long as it is, so I just won't get all that much done if I don't use it wisely. And this syntax is easy enough. It makes sense to me, so let's use it and move on. Okay, now we've got things looking a bit differently. Because we got PDB. But the good news is it ran successfully. Okay, so let's see how it runs without PDB. We got a typo in there, so let's go and fix that. So the command is loggin. So we have a typo where it says loggin instead of logging. So I'm going to need to find that. Found it. Okay, so now we've got root logger object has no attribute add handler. The correct attribute name is add handler. So let's fix that typo. Yep, so it's right here. Okay, and now we've got different output. It looks a bit strange. I'm not sure why it looks so strange. Oops. Yeah, so I mean the reason it looks strange is because it's not filled in. It looked better before, but look, as I said, time is of the essence. Even though I've got a good hour of it, an hour for me does not seem to be enough a lot of the time. So let's keep moving. A lot is happening here. The root logger is requested by calling getLogger without any arguments, and the level is set at debug. This is a good default to have since other child loggers can modify the level. Next, the file logger gets configured. In this case, it tries to create the file logger that will fall back to a temporary location if it can't write to it. It then gets set at the info level, and its message format is changed to include a timestamp, useful for file-based log files. Note how at the end, the file logger gets added to the root logger. It feels counterintuitive, but in this case, the root configuration is being set to handle everything. Adding a stream handler to the root logger will make the application send logs to both the file and standard error at the same time. So we're going to skip that. It's just been not working too well for me at this time, and we just want to get through the book. In this case, you know what? Never mind. I always second guess myself, and it's not a good instinct, but I want to get this under my fingers, so let's not do that. Let's type it out. Because logging is just really important, and I want to... Oh, and you know what? This is stuff we already added. Okay, yeah, it's already right here, so let's just keep going. So I'm going to do Control X, and then I'm going to select No. In this case, the base format was used because it's going to the terminal, where timestamps can cause excessive noise. As you can see, it takes quite a bit of configuration and settings, and it gets very complicated once we start dealing with different loggers. To minimize this, a separate module with a helper that sets all these options is preferable. As an alternative to this type of configuration, the logging module offers a dictionary-based configuration where the settings are set in a key value interface. The example below shows how the configuration would look for the same example. To see it in action, add a couple of log calls at the end of the file, execute directly with Python, and save it to a file called logtest. So it looks like I actually reread a lot of what I had already read, but I don't remember reading it at all, so perhaps that's not a bad thing. The root logger is the parent, and a new logger is called myApp is introduced. Executing the file directly gives output in the terminal as well as in a file called application.log. The output is repeated because we configured both, but that doesn't mean they need to be. The formatting changed for the file-based logger, allowing a cleaner view in the console. Using dict config helps better visualize where things go and how they all tie together versus the more manual example earlier. For complicated setups where more than one logger is needed, the dict config way is better. Most of the web frameworks use the dictionary-based configuration exclusively. Sometimes the logging format is overlooked. It's often seen as something cosmetic that provides visual appeal to a human reading the logs. While that is partly true, it is nice to have some square brackets to designate the logging level. For example, what we see there. But it can also be instrumental when other specifics of the environment, such as production, staging, or development, need separation. It might be immediately clear to a developer that the logs are from the development version, but it is extremely important to identify them if they are being forwarded around or collecting in a central place. Dynamically applying this is done with environment variables and the use of logging.filter in the dict config, import os from logging.config, import dict config, import logging. So we've got some code written there. We're just going to skip it and keep on going. I've had a heck of a time with these code examples, so we're just going to keep on going. There is a lot going on in this example. It might be easy to miss a few things that got updated. First, a new class called EnvironFilter, which uses the logging.filter as a base class, was added, and it defined a method called filter that accepts a record argument. This is how the base class wants this method to be defined. The record argument gets extended to include the app_environment variable that defaults to Devil. Then in the dict config, a new key is added, filters, that names this filter the EnvironFilter, pointing to the EnvironFilter class. Finally, in the handlers key, we added the filters key that accepts a list. And in this case, it will only have a single filter added, EnvironFilter. The defining and naming of the filter feels cumbersome, but this is because our example is trivial. In more complex environments, it allows you to extend and configure without boilerplate filling the dictionary, making it easier to update or extend further. A quick test in the command line indicates how the new filter shows the environment. In this example, a basic pecan application is used. Okay, so we've got the default environment of Devil works, and changing it to production is one environment variable away. Alright, so we're going to skip this as well, move on to the next section, common patterns. I must say I'm feeling a lot of anxiety as I go through this because, you know, it's one thing to say, like, you know, all the motivation, if you follow like David Bumball, and even if you follow like Jocko, or what's his other name, like David Goggins, you know, they're gonna tell you, like, you know, get up at 2 a.m. and, like, you know, work out for 5 hours and all this, but like, you know, that's for working out, you know, I guess that makes sense. Like, you're gonna burn calories and you're gonna build muscle, but like, when it comes to something like this, it's like, you know, I'm putting a lot of time and effort into reading this book, but, you know, am I burning calories? Am I gaining muscle? Like, a lot of this just doesn't seem relevant to me. And not only that, it just doesn't seem effective. Like, you know, if you go on a run, you're going on a run, but if you're reading a book, it depends a lot on the book. I mean, I guess an analogy could be, you go on a run and for some reason, you know, the only way you can run is by getting in a car and driving. You know, that's not running. but you know, you're putting the effort into running. It's just the effort isn't actually going into running. I guess a good example would be if you drive to a running trail, you drive 2 hours to a running trail, you run for 5 minutes, and then you get back in your car and drive 2 hours back. You know, sometimes it feels like that's what I'm doing when I'm trying. You know, I'm actually putting my running clothes on, I'm going out to the running trail, but just in what it takes to actually do that, I'm just not getting in a good run. It feels like that with this book. Like this book just isn't adequate. I thought this would be good, but it just does not. It's just not doing it for me right now. Hopefully it'll get better though, and it's just this section. We've still got about 60% of the book to get through. The logging module offers a few good patterns that aren't immediately obvious, but are quite good to use as much as possible. One of these patterns is using the logging.exception helper. A common workflow looks like this. Okay, so the logging.exception helper, we should see. Okay, I don't see that. Yeah, I don't see logging.exception anywhere. Okay, I was expecting to see this logging.exception somewhere, but I don't see it anywhere in this code. And the formatting as well. See, this is another reason why I'm not happy with this book. Like the formatting is not, formatting is so important in Python too, because white spacing is what tells you like where your code applies to. Does it apply to the except portion? You know, that depends on white space. So if the white space is not preserved, it's really hard to read the code. This type of workflow is problematic on several fronts. It primarily eats the exception and just reports the string representation of it. See, and that's bothersome to me too. Like, stop showing me problematic bad code. Just show me the good thing. And like, if the exception isn't obvious, or if it happens in a location that is not immediately evident, then reporting type error is useless. But then why do they show me this? Yeah. When string replacement fails, you can get a value error, but if the code is obscuring the traceback, then the error doesn't help. Where did that happen? We know it happens when expensive operation is called, but where? In what function, class, or file? This type of logging is not only unhelpful, it is infuriating. The logging module can help us log the full exception traceback. Oh, okay. So now we're going to see, okay, perfect. So now we've got logging.exception as I thought we would see here. So this is an alternative you could do to logging.exception. You could do logging dot and then the type error that you're getting. But I'm not sure why you would do that. The book, in fact, says not to do that. So I'm not sure where that example is coming from. Are they expecting that example to show up a lot in the real world from programmers who do not know better? I'm not sure why they showed that and didn't just immediately show this. Because to me, like, you know, I'm new to this. It doesn't make a difference which one it is. So I just want to be told the proper way to do it. I really don't care to learn about improper ways to do it. The logging.exception helper will push the full traceback to the log output magically. The implementation doesn't need to worry about capturing error as it was doing before, or even try to retrieve useful information from the exception. The logging module is taking care of everything. Another useful pattern is to use the built-in capabilities of the logging module for string interpolation. Take this piece of code as an example. The statement is requiring 2 string replacements, and it is assuming that arguments is going to have 2 items. If arguments fails to have 2 items, the above statement will break the production code. You never want to break production code because of logging. The module has a helper to catch this, report it as a problem, and allow the program to continue. This is safe, and it is the recommended way to pass items to the statement. The Elk Stack. Just like Linux, Apache, MySQL, and PHP were known as LAMP, you often hear about the Elk Stack, Elasticsearch, Logstash, and Cabana. This stack allows you to extract information from logs, capture useful metadata, and send it to document store, Elasticsearch, which then uses a powerful dashboard, Cabana, to display the information. Understanding each piece is crucial for an effective strategy when consuming logs. Each component of the stack is equally essential, and although you may find similar applications for each, this section concentrates on their actual roles in an example application. Most production systems have been around for a while, and you will rarely get the chance to redo infrastructure from scratch. Even if you are lucky enough to get to design infrastructure from the ground up, it is possible to overlook the importance of log structure. So it looks like what they mean by infrastructure here is actually software. I think of that term a little bit different. With my network engineering background, I'm thinking of like wiring, routers, and switches, and network design when I hear the word infrastructure. But it looks like they are talking about writing code from scratch, and they're saying that's something you'll rarely get the chance to do. A proper log structure is as important as capturing useful information, but when the structure is lacking, Logstash can help. When installing Nginx, the default logging output is similar to this. Some parts of the log statement are straightforward, such as the HTTP method, a GET, and the timestamp. If you can control the information, drop what is not meaningful, or include needed data, that is fine as long as you have a clear understanding of what all of these components are. The configuration for the HTTP server has these details in etc nginx, nginx.conf. When you first look at the output, you might think that the dashes were missing for information, but this is not entirely correct. The dashes were missing. Yeah, see, with this formatting all messed up, I don't even have like a assessment of what I think of this initially. Like it's just not clear enough with the formatting all messed up like that. And then I of course can't copy and paste it from this book, so I'm pretty unhappy with this. But let's just keep going. Just to say that I finished this book would I think boost my self-confidence and make me feel like I've accomplished something. When you first look at the output, you might think that the dashes were for missing information, but this is not entirely correct. In the log output example, 2 dashes follow the IP. One is just cosmetic, and the second one is for missing information. The configuration tells us that a single dash follows the IP, and then by the remote user variable, which is useful when authentication is involved so that the authenticated user is captured. If this is an HTTP server that doesn't have authentication enabled, the remote_user can be dropped from the configuration if you have access and permission to change the nginx.conf file, or it can be ignored with rules that extract the metadata from the logs. Let's see in the next section how Logstash can help with its vast number of input plugins. Tip: Elasticsearch, Logstash, and Cabana are usually not available in Linux distributions. Depending on the flavor of Linux, the proper signing keys need to get imported, and the package manager needs to be configured to pull from the right repositories. Refer to the installation sections. on the official documentation. Make sure that the FileBeat package is also installed. This is a lightweight yet powerful utility for log forwarding. It should be used in logs to Logstash later. Alright, this section is on Logstash. The first step after deciding to go with the Elk Stack, which I guess they don't tell you why you should decide to go with that over LAMP, especially if the Elk Stack is not available by default in Linux. I would think LAMP would be the better option. I don't understand why Linux did not choose to include that by default. Is to hack some Logstash rules and extract information from a given source, filter it, and then ship it to a service like Elasticsearch in this case. After Logstash gets installed, the path etc logstash becomes available with a useful conf.d directory where we can add multiple configurations for different services. Our use case is capturing Nginx information, filtering it, and then shipping it over to a local Elasticsearch service that should already be installed and running. To consume logs, the FileBeat utility needs to be installed. This is available from the same repositories that you enabled to install Elasticsearch, Cabana, and Logstash. Before configuring Logstash, we need to ensure that FileBeat is configured for the Nginx log files and the location of Logstash. After installing FileBeat, add the log paths for Nginx and the default Logstash port for localhost. The configuration in etc FileBeat, FileBeat.yml, which is a YAML file, should have these lines defined or uncommented. So they didn't give me any instructions for installing FileBeat. I guess you can just do a apt-get install, but I'm gonna just try to plow through this section. Honestly, I can't imagine anything about this being relevant for me at the time being, so we're just gonna get first exposure and skim through this. We won't do an in-depth and lasting study on this topic until I need to. This allows FileBeat to look at every single path in var log nginx and then forward it to the localhost instance of Logstash. If a separate log file for another Nginx application is required, it gets added here. Other defaults in the configuration file might be present, and those should be fine to leave as is. Now start the service. Now create a new file in the Logstash configuration directory and name it nginx.conf. The first section that you should add handles the input. The input section indicates that the source of the information will come from the FileBeat service using port 5044. Since all the file path configuration is done in the FileBeat configuration, not much else is necessary here. Next, we need to extract the information and map it to keys or fields. Some parsing rules need to be put in place to make sense of the unstructured data we are dealing with. For this type of parsing, use the Grok plugin. Append the following configuration to the same file. The filter section now defines the usage of the Grok plugin that takes the incoming line and applies the powerful combined Apache log, a collection of regular expressions that can accurately find and map all the components of the web server logs coming from Nginx. Finally, the output section needs to set where the newly structured data should go. This means that all structured data gets sent over to the local instance of Elasticsearch. As you can see, the configuration for Logstash and the FileBeat service was very minimal. There are several plugins and configuration options that can be added to further fine-tune the log collection and parsing. This batteries included approach is excellent for getting started without having to figure out extensions or plugins. If you are curious, browse through the Logstash source code and search for the grok patterns file that contains combined Apache log. The collection of regular expressions is quite the sight. And we're going to skip that and keep on going. Elasticsearch and Cabana. After installing the Elasticsearch package, there is little that you need to do to have a local setup running and ready to receive structured data from Logstash. Make sure the service is started and running without problems. Similarly, install the Cabana package and start the service up. Even though Cabana is a dashboard and the Elk Stack is not built with Python, these services are so well integrated that it demonstrates what great platform design and architecture truly are. After starting Cabana for the first time, while browsing through the log output, it immediately starts looking for an instance of Elasticsearch running on the host. This is the default behavior of its own Elasticsearch plugin with no extra configuration. The behavior is transparent and the messaging tells you that was able to initialize the plugin and reach Elasticsearch. I hate this section of the book. I hope it gets better. I think this is a new author. The last section was pretty good, I thought, but this section is just garbage. You can just read the official docs and it'll be fine. See, I want these books because I want them to guide me through like detailed like examples and like projects and kind of have me like, I want them to offer me something that an advertisement or an official doc doesn't offer me. But the problem with that is official docs are usually pretty darn good, so I really feel like this is the wrong approach, but we're going to keep going and hopefully try to finish up this book, although it's going to take me a while. After changing the configuration to an incorrect port, the logs are very clear that the automatic behavior is not quite working. Once Cabana is up and running along with Elasticsearch on the correct port, FileBeat, and Logstash, you will be greeted with a full-featured dashboard and plenty of options to get started, as in Figure 7.1. So that would be cool to get this dashboard up and running, but we're just going to keep on going. Hit the local instance of Nginx to get some activity in the logs and start the data processing. For this example, the Apache bookmarking tool, AAB, is used, but you can try it with your browser or directly with curl. Without doing anything specific to configure Cabana further, open the default URL and port where it is running. The default view offers lots of options to add. In the Discover section, you will see the structured information from the requests. This is an example JSON fragment that Logstash processed and is available in Cabana, which is sourcing the data from Elasticsearch. Okay, we're going to skip that and move on. Critical keys like verb, timestamp, request, and response have been parsed and captured by Logstash. There is lots of work to do with this initial setup to convert it into something more useful and practical. The captured metadata can help render traffic, including geolocation, and Cabana can even set threshold alerts for data for when specific metrics go above or below a determined value. In the dashboard, this structured data is available to be picked apart and used to create meaningful graphs and representations as shown in Figure 7-2. Kind of looks like Splunk a bit. As we've seen, the Elk Stack can get you started capturing and parsing through logs with minimal configuration and almost no effort. The examples are trivial, but should already demonstrate the immense capabilities of its components. More often than we would like to admit, we've been faced with infrastructure with a cron entry that is tailing logs and grepping for some pattern to send an email or submit an alert to Nagios. Which I wish they would go into more. I don't understand why that's a bad thing. Oh, okay, well, they're going to tell you. Using capable software components and understanding how much they can do for you, even in their simplest forms, is essential to better infrastructure. I disagree with that. And in this case, better visibility of what the infrastructure is doing. I fundamentally disagree. So first of all, you can't just say, use this because it's better. You got to say why it's better, how it's better. Like, this did not demonstrate that. Okay, there's a nice, pretty, GUI, and there's, it looks better. Okay. Like, it doesn't matter how something looks, it matters what it tells you. It matters the density of the information, it matters the relevancy of the information, it matters the timeliness of the information. So how does this make the information more dense, more timely, and more relevant? I would argue that it doesn't. It actually makes it less dense, less timely, and less relevant, because it makes it less dense because you've got all this extra stuff on the screen. You don't need to see that. What does that matter? It makes it less timely because you've got to go through and set this all up and teach everyone else how to use it. And it makes it less relevant because now you've got, all this extra stuff, where if you would have just put in a cron entry and tail the logs and grepped for what you want, like, you're done. You got what you need, and you can go about your merry way. Like, I'm sorry, I've got to interject, and I've got to say at this point, I fundamentally disagree with the points the authors are making right now. It is not better. It is not essential to better infrastructure to use a buzzwords and new products. Like, it is not essential to better infrastructure to use fancy flash in the pan things. What's essential to better infrastructure is timeliness, relevancy, and density, efficiency too. Like, I'm sorry, I have to say this chapter was awful. There were typos all over it. It just said that using this is better because it's better. It didn't actually explain how or why it's better. In fact, it seemed to make a case for it being worse because it showed just how difficult it is to set up. None of the examples worked. So I'm sorry, I'm really frustrated with this chapter. Let's read the exercises, but this chapter was so horrible. I think I'll probably just skip the exercises and just go on to the next chapter. None of this is relevant to me. None of this was written properly. None of the points in this chapter were argued for properly. In fact, the opposite of the points they're making seem more feasible to me after this chapter. So bad chapter. I'm sorry I wasted my time. I'm sorry I wasted all of your time. And let's read the exercise and go on to the next one. What is fault tolerance, and how can it help infrastructure problems? So this is probably a good question, but we're not going to go and reread the chapter to find that. We're going to go straight to Google, and we're going to find an answer on Google. Okay, fault tolerance is the property that enables a system to continue operating properly in the event of the failure of, or one or more faults within, some of its components. Perfect. Really good explanation. much better than what's ever provided in this book. In fact, I don't think there was a explanation provided in this book. But how can it help infrastructure systems? So we know because fault tolerance is the ability for a system to continue to operate in a fault, it can help with uptime, it can help with troubleshooting, it can help with making updates to the system, swapping out hardware and systems. If you can swap out hot swappable components are components that you can take out and put back in and change without bringing the system down. So fault tolerance, all kinds of benefits. All right, what can be done for systems that produce huge amounts of logging? So for this one again, we're going to go directly to Google. Okay, oops, my bookmark is gone, so I'll edit. We'll go directly to Google with this question. I'll just type out the full question. Okay, I guess my answer for that is going to be centralized logging. And I'm sorry, I'm did the search on my other screen here, just because it's easier for me to manage. But once I find a good answer in here, I'll put it on my other screen. Yeah, I don't know. I guess my answer for this is you can make the logging centralized. Okay, next. I don't know if that's right or wrong. I'm not going to go back through this chapter to find out. This chapter was awful. All right, next exercise. Explain why UDP might be preferred when pushing metrics to other systems. Why would TCP be problematic? So the difference between UDP and TCP is UDP is stateless, TCP is stateful. If you send a UDP packet and the packet is not received, you don't worry about it, you just keep sending. And if they're never received, you just keep sending, nothing happens. TCP, you need, you form a three-way handshake and you keep track of the packets that you send. And if they were not received, you resend them. So things can come in on a different order, and they've got to get reordered based on a sequence number they have. So I guess a reason UDP might be preferred is you get more your logging is more timely and more relevant, and your timestamps are more accurate to when an event actually occurred. And it's not really that important to just get every single logging message that comes in. That sort of thing, like having a correct timestamp, is more important, because if it's having an error, it will continually send out these log messages. So as long as you receive one of them, you've got enough information to go on. So that's why UDP might be preferred, is because you get your updates are kind of more pure. They're not used by the mechanisms of TCP to provide a stateful connection and handle dropped packets are not applied to your metrics, or are not applied, and therefore allow your metrics to get pushed a little bit faster. All right, so especially for huge files of metrics, if it doesn't make it there, that's fine, don't resend it. We'll just try to send it again. We don't need a mechanism to do that and to add time onto our metric pushes. All right, so describe the differences between pull and push systems. When would one be better than the other? So I don't know. We'll go straight to Google. Okay, so in a push-based supply chain, products are pushed through the channel from production up to the retailers. So I don't think they're talking about that. I think it's more of a like a DevOps. Yeah, okay. They're talking about a DevOps pipeline. So I think this is what they mean. So most CI/CD tools available today use a push-based model. A push-based pipeline means that code starts with the continuous integration system and then continues its path through a series of encoded scripts to push changes to the Kubernetes cluster. The reason you don't want to use your continuous integration system as the basis for your deployments is because of the potential to expose credentials outside of your cluster. While it is possible to secure your CI scripts, you are still working outside the trust domain of your cluster, which is not recommended. In a pull pipeline, a Kubernetes operator deploys new images from inside of the cluster. In our case, Weave Cloud provides one to you. The operator notices when a new image has been pushed to the registry. Convergence of the cluster state is then triggered and the new image is pulled from the registry. The manifest is automatically updated and the new image is deployed to the cluster. With a pipeline that pulls an image from the repository, your cluster credentials are not exposed outside of your production environment. So the difference between a pull and a push system is your continuous integration. It's how your yeah, I don't know. I have no idea. It sounds like the difference is credentials. But let's just move on. So produce a naming convention for storing metrics that accommodates production environments, web and database servers, and different applications names. I'm just going to go ahead and say no, I'm not going to do that. Case study question. Create a Flask application that fully implements logging at different levels, info, debug, warning, error, and sends a metric like a counter to a remote Graphite instance via a statsd service when an exception is produced. I mean, that sounds awesome. It sounds like a really good thing for me to do. I'm pretty upset with this chapter though. This is just not something I currently do or necessarily see myself doing in the near future. So, you know what? I think I'm gonna skip this. And but what I will do is highlight this. And then if I come back to this book later, frantic, oh no, I need to do something like this, now I can find where it was. So let's check the notes, make sure we don't have any extra bookmarks. Looks like I got one. Okay, and then I'll add a bookmark here, and that's the end of chapter 7. So thanks for watching, and I'll see you in chapter 8.